our last video on Lewis dot diagrams. We've had a look at those things that do obey the octet rule, so how to learn how to do them. We've had a look at those that break the octet rule. Now we're going to put those together and have a look at polyatomic ions, so atoms made up of more than one ions made up of more than one atom. The first two I've got there, carbonate and hydronium, will obey all the rules like the octet rule and stuff, but the last one doesn't, even though you could actually put together a structure for it which obeys the octet rule. It has the right number of electrons and everything. It just doesn't want to work. It's when we do what's called X-ray crystallography on these sorts of things, what was it, X-ray diffraction, I'm not sure. But when we look at the shape of it, we actually see it's wrong. It's not got the bonds we predict. So that's why I'm going to show you this one. It's a nice exception to the rule. Okay, carbonate. If we were doing this as a molecule, we'd say, oh, there's 4 electrons here. There's 3 times 6 for the oxygen. But now we're going to add the 2 for the negative charge. Okay? So we're going to have 4 plus 18 plus 2. My quick math says 24. I hope it's correct.
Yep.
Okay. Again, because it's got carbon, we'll put carbon in the middle. And we're going to put the 3 oxygens around it. Then fill in. Then we might have to move these, so I'm doing this in pencil if it was on my test paper. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. But the carbon's not obeying the octet rule, so I'll move any 2 electrons over to make a double bond. I'm not quite finished. What I have to do is put a square bracket around it and put the charge on the outside of the bracket. Now I've got a Lewis structure for a polyatomic ion. Hydronium, it's going to be the same idea. 3 times 1 for each hydrogen plus 6, but it's a positive charge, which means it's lost an electron. So I'm going to go minus 1. I'm going to get rid of that charge. So get rid of that one that's been lost by charge. So I've got a total of 8 electrons. Now this one I know hydrogen's written first, but oxygen will be the central atom because there's only one of them. So we'll have oxygen with 3 hydrogens coming off it. Hydrogen doesn't obey the octet rule, so it's complete. So there's only one other place to put any remaining electrons. So 2, 4, 6, I need 8. I'll put them there. Again, I haven't quite finished. That's not correct until I put the square brackets. Excellent, and the charge. Right, this last one, sulfate. Sulfate, in an exam, I'm going to give you 2. Both would be accepted. The second one I give you is more correct because it's actually what it really is. When we look at its structure with X-rays, okay? And it's not looking at it through an X-ray machine like your bones. It's the way that it diffracts an X-ray, all right? So, through the bonds. Okay. Sulfur is 6. And we've got 4 oxygens, which are also 6, and I've got 2 electrons. Whoops. So I've got 32 in total. 32 electrons. Okay. Again, I'm going to infer that sulfur is the central atom because there's only one of them. So it's likely. And if I look at that, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. That should be fine. I need 32 electrons, I've got 32 electrons. That should be fine. If I put the square brackets and 2 minus with it. There's a problem with that. We actually know that it's got double bonds, 2 double bonds and 2 single bonds in it when we look at it through X-ray diffraction. So we know it's wrong, which is frustrating. So in reality, it's this. 2 double bonds, 2 single bonds, which is a bit strange, but that's what it is. So,
What do you mean in reality?
so it really has 2 double bonds and 2 single bonds, not 4 single bonds. We could draw a Lewis structure that works, obeys the octet rule, has the right number of electrons with 4 single bonds. That'd be correct for a Lewis structure, but it's not actually what the iron really looks like. The iron really has 2 double bonds and 2 single bonds. So I'm giving you both. And both would have to be accepted in NCEA because they're both valid using the rules you have to apply. Okay?
So are we allowed to do...
Look, my suggestion is learn the right one because that's correct. My suggestion is learn it as a strange one and learn the correct one. That'd be my suggestion. So yeah. It's also given on page 87 of Continuing Chemistry, so if you did want to have a look at that, if they're going to go through the effort to outline it in the book, then I'd expect you to use the one that I've left on the board rather than the one with 4 single bonds. Okay. And that should give you all the ammo to be able to do any Lewis structure that you encounter or are asked to do. Alright, so there we go, we'll stop from there.